Cubic, you remember what a cubic looks like? Chair. Looks like a chair. Looks like that chair. So if we had a graph, we could easily identify what type of function it is. From a table, it's really not too bad either. We're going to be looking at the differences. You guys have on your notes this first table. It's a linear function. What I am asking you to do is to find the difference in these table values. And let me open up the Word version, or the PowerPoint version of this. It'll be a little bit easier to look at, understand. So this is our linear function. Okay. We are going to look at the first difference. In other words, difference means what? Subtraction. So we're subtracting. If I take 0 minus negative 2, what do I get? Positive 2. So I want you to do that. Next to this, put plus 2. The difference between 0 and negative 2 is a positive 2. So write that down, plus 2. The difference between 2 and 0, well, 2 minus 0 is 2. That's where I got 2. The difference between 4 and 2 is 2. The difference between 6 and 4 is 2. We would say that our common difference is 2. Our common difference is 2. So that tells me that it is linear. The pattern in the y column shows the first difference between the y values. The first difference is the same. Guys, I need you up here not doing other things, please. The first difference is the same. If the first difference is the same, you say it's linear. You're adding or subtracting the same number to get to the next number. So in this case, we're adding 2 to each. Is that correct? Adding 2 to negative 2 to get to 0. 0 plus 2 is 2. 2 plus 2 is 4. 4 plus 2 is 6. So this would be an example of a linear function. Let's look at one that's not linear. The next example, this one's actually going to be quadratic. Now to help us figure this out, we need to look at the first difference. Well, 3 minus 2 is positive 1. So I would put plus 1, positive 1. Please do this with me. If you look at your second difference, 6 minus 3 is 3. So our next digit would be 3, our next difference. 11 minus 6 is 5. The next difference would be 5. 18 minus 11 is 7. Is our first difference the same? No, I know right off the bat this is not a linear function. This table does not represent a linear function. So let's look at the second difference. Thank you very much. Look at the second difference. In other words, the difference between 3 and 1. What is 3 minus 1? 2. Our second difference would be said to have a positive 2. Everybody okay with where I got that 2 from? I took 3 minus 1. Gives me 2. Keep going. 5 minus 3 is 2. So we say that is also 2. 7 minus 5 is 2. Our second difference. This first group of numbers here is called our first difference. 1, 3, 5, 7. Called our first difference. The second difference are all 2. If the second difference is the same, then we say it is quadratic. Now, think about this for a second. In a quadratic equation, what is the highest exponent? Squared. It's a 2. Our common difference is the same in the second difference. Second being 2. It won't necessarily always be 2 here. It just happened to be. But the second difference is a 2. So this would be a quadratic. It says the pattern in the y column shows a common second difference between the y values. We weren't adding the same value every time in the first difference, but the second difference we were. We were adding 2. Look at this table here. Sometimes your vertex is part of your table. Do you remember what I mean by vertex? We've talked about that. graph. Vertex of a quadratic, vertex of a parabola is where? Okay, it's the very, very bottom of your graph. So you've got that U shape. The very, very bottom point is called our vertex. If that vertex, that point happens to be on our table, it's going to look a little funny. Let's look at that to see what it's going to look like. What is the difference between 4 and 7? 4 minus 7? Not 3. Negative 3. Write this in, please. Write this in on your table. The difference between 4 and 7 is negative 3. Go to your next difference. The difference between 4 and 2, 2 and 4 is 2 minus 4. 2 minus 4. Negative 2. Write that in. The difference between 4 and 2 is 4 minus 2 is not negative 2. It's 2. Positive 2. 7 minus 4 is 3. Is our first difference the same? Clearly it's not linear. So let's decide, is it quadratic? Let's look at our second difference. Well, negative 2 minus negative 3 is? Nope, negative 2 minus negative 3. Not negative 1. 1. Oops, it didn't fill it in. There we go. 2 minus negative 2 is 0. What I'm stating here on the screen, it says opposites. We have negative 2 and positive 2. Those are opposite numbers. So the vertex must be here, somewhere right between these two numbers. Okay? The vertex is here at 0, 2, and it is in this case. If you look at your next difference, 3 minus 2. 3 minus 2 is 1. Our second difference is the same, other than this middle point. If your vertex happens to be in your table, that middle point, or one point in there, may not necessarily give you the same second difference. But these two values are the same, correct? So it tells me that it's a second difference. The second difference is the same. You know that it is quadratic. Look at this example. This is an example of a cubic function. So the first difference, if it's the same as linear, if the second difference is the same as quadratic, what do you think cubic's going to be? Third difference. Let's look. What is negative 1 minus negative 2? 1. You have to be able to know your subtraction here. It is a positive 1. 6 minus negative 1 is? It's what? No. 6 minus negative 1. No. 7. 25 minus 6. 19. 62 minus 25. It's what? 37. Is our first difference the same? No, we know it's not linear. Our first difference is not the same. Let's look at our second difference to see if it's quadratic. 7 minus 1 is? 6. 19 minus 7 is? 12. 37 minus 19 is? 18. Is our second difference the same? It's not. So let's look at our third difference. 12 minus 6 is 6. 18 minus 12 is? It is also 6. The third difference is the same. What does that tell me about this function? It is cubic. The first difference is the same. We say it's linear. The second difference is the same. We would say quadratic. The third difference is the same. We would say it's cubic. Yes, but they won't give you, that is true, Aubrey. If they just give you the function and the exponent is the hint, but many times they'll just give you the table and they won't tell you, they won't give you the function. So it says the pattern in the y column shows the constant third difference between the y values. Look at this next table, which I believe is on the front sheet of your paper. Let's go ahead and find the difference. What is -1 minus -8? 7. 0 minus -1 is? Please follow along with us. 0 minus -1 is 1 minus 0. 8 minus 1. Is the first difference the same? It's not. It's not linear. Look at your second difference. 1 minus 7. -6. 1 minus 1. 0. 7 minus 1. 6. Is our second difference the same? No, we have -6, we have +6 and 0. It's not. Look at our third difference. 0 minus -6 is 6. +6. 6 minus 0 is 6. The third difference is the same. What does that indicate about this table? Cubic. It is cubic. So what I'm going to do next is you have clickers. I am going to set this up where you're going to submit your answer. We will let A be linear. B is quadratic. And C is cubic. Just a second to get this done. You can go ahead and start on that first table on the back side. So flip your paper over to the back side, please. All right, so the clickers are set up for this problem. I believe it's your next problem on your sheet. What I'm asking you to do is identify whether this is linear A, quadratic B, or cubic C. Somebody still working on that first one? Make sure you submit your answer. Everyone? Okay, we're in. Most of you said B. Look at this one, please, with me, guys. I don't want you. You can work ahead as we're waiting, but go ahead and stop and follow along with me. If you look at this graph, or this table, excuse me, the first difference, 3 minus 1 is 9 minus 3. 19 minus 9. 33 minus 19. 14, is that right? Okay. The first difference is not the same, is it? So we know it's not what? Look at the second difference. 6 minus 2 is 10 minus 6. 14 minus 10. The second difference is the same, so what does that tell you about this table? It's quadratic. Now, is there another way we could have done this without finding the difference? What could we have done with these points? Graph them. Now, these are not going to be really pretty because they're not perfect. I'm just going to sketch a few of these. Somewhere up there. We'll do something up there. That's what it looks like if we plot those points. They didn't take any negative values, did they? Okay? But these are clearly not in a straight line. It's more of a curve. So that should give you a clue that it's probably going to be either quadratic or cubic. Now, if you had put in, you could have continued this pattern in the opposite direction. You could have gone -1 up here. Subtracted 2, -1. Wait, no, that wouldn't be right. I can't continue that pattern that way. But you could have clearly seen it's not going to be linear, right? That's my point of pointing this out. It's not linear, it's not a straight line. It is quadratic. Right, go on to that next one if you would, please. Once you get this one done, if you want to work ahead, you can work the next one. Need 2 more in, please. Good. Most of you are saying it's cubic. Let's look at this one. If you go ahead and subtract your differences, again, if you're working ahead, just go ahead and stop for the time being and follow along with me. If you go ahead and subtract your differences here, 18 minus 20 is -2. 4 minus 18 is -14. -38 minus 4, -42. And -124 minus 38, -86. Clearly it's not linear, correct? First difference is not the same. Look at your second difference. -14 minus -2. -12. -42 minus -14. -28. -86 minus -42. -44. The second difference is also not the same, so we know it's not quadratic. Look at your third difference. -28 minus -12. -16 and -44 minus A negative 28? Negative 16 also. The third difference is the same, so it tells me that it is cubic. Please fix it on your notes if you did miss something. Have some good references to look back on. Don't leave them as incorrect. So look at the next table. Should identify what type of function this is. Is it linear? A, quadratic B, cubic C. Yeah, these are opposite, right? Negative 2 minus 2. So that's going to tell me that that's the vertex. These are opposite from here. That's the vertex. What does that tell you? There's only one that has a vertex. There are those. Most of you said, or all of you said A. A is correct. You'll do your differences here. 5 minus 8 is negative 3. 2 minus 5, negative 3. Negative 1 minus 2. And negative 4 minus negative 1. But the first difference is the same. That tells us this is linear. Last one, this table. Linear, quadratic, or cubic. Negative 1 minus negative 7. Two more in here. So make your answers, please. Most of you said quadratic, which actually is correct. If you look at your differences, negative 1 minus negative 7 is how much? 3 minus negative 1. 5 minus 3. 3 minus 5. Negative 1 minus 3. First difference is not the same, so we know it's not linear. Look at your second difference. 4 minus 6. 2 minus 4. Negative 2 minus 2. Negative 2 minus 2 is 0. It's negative 2 minus 2. It's negative 4. Negative 4 minus a negative 2. Negative 4 minus a negative 2. Not 2. Negative 2. Now, somebody might say, well, your second difference is not the same. Well, look right here, please. What did we say if we have opposite numbers? What does that mean about this point here? That's your vertex. Remember, we did an example just like that, didn't we? That would be your vertex. Well, there's only one that has a vertex. Which one's going to have a vertex? So one type of function that has a vertex. What type is it? Quadratic. Has to be quadratic. Letter B. You might have one number that's off in there. Now, one number that's off will help you, should help you a little bit to determine that that is your vertex. And in fact, it is a quadratic function. I do have some tables for you to look at to determine if they are linear, quadratic, or cubic. There's a front and back to this assignment. Tomorrow we're going to take this a step further. Not only are we going to identify if it's linear, quadratic, or cubic, but we're going to write the rule. So it's important that you do your homework so you're able to do tomorrow's work as well. You have plenty of time to be able to get most of this done, if not all of it.